Math Kimchi, and in this video I want to show you guys a multiplayer game I made using Java, Java sockets, and also Java Swing, which are all default Java packages. And yeah, I'll start off by playing the game. So you can see that when I control my client here on this client, so this one, it also shows the changes on this client, and this client can also move around, and it will show on the blue client. And yeah, it's a pretty simple game. There are just four basic moves. You can go left and right with A and D characters, and you can jump using the space bar, and you can also shoot using the enter key. And when you get hit by a bullet, you have to replay the game, or you have to respawn if you want to play again. And yeah, right now I'm playing it on my own computer. Both of the clients and also the server. You can see the server UI here. And yeah, it's not really fun playing by yourself because there's not really a way to connect to both of the clients at the same time, or at least like interact with them, because your window focus can only be on one at a time. But since this is multiplayer, it is also possible to play on different computers. So if I start this over, you can see that when I try to create a new server, it first asks you the team, or the game mode, which is either red versus blue or also free for all. And then it asks you for the port number, which isn't that important as long as it's big enough. I think as long as it's over 1000, or maybe it's like 200 or something, but 1234 is a safe port to use. And you could start the server, and right now I choose red versus blue, which is what you saw earlier, where there were blue people and also red people, and this is like a team battle. So yeah, there are three people now, and you could tell which team they're on because of the blue mask or the red mask. And yeah, you can't shoot your own teammates because that would be unproductive. But you could shoot the other team. And yeah, that's, I guess, the objective of the game. And you could see when I'm running the server, there's a new screen, and it tells you the port, which is the one you typed in at the beginning. But then it also tells you the IP address, and this is useful if your friends on another computer want to join. So pretend like this was on another computer, then I would type in this IP address to join. Except there's one important thing, and it's that both of the computers have to be on the same Wi-Fi. So you can't just connect to someone from another city or something. You pretty much have to be in the same room to play. And if you're playing on your own, you can retype this IP address, or you could just leave it as localhost, and your ports have to be matching no matter like who you are. You could be on the same computer or a different one, but these two numbers have to say the same thing. And if you are connected to the Wi-Fi as the server and it's showing your IP address is 127.0.0.1, then it means something's not working. And it would just be better if your friends hosted the server. But anyways, you can like join the game. Oops. That's weird. I guess something broke. But yeah. You should be able to join the game if you're on the same Wi-Fi. And anyways, that was like the very basic gameplay of my game. And let me go over the basic way I created this game. So first of all, I want to I guess cite my sources for inspiration, and the first one is from WoodCode, and is from the video where WoodCode basically explains how to make a chat room with multiple clients using Java sockets. And this is a really good video, even if you don't want to make a chat room, because it just explains how to use Java sockets well. And there's also Van Zieben's series on making a game from scratch in Java, and this is also a cool video. And yeah, both of these were pretty helpful in my own projects, and I'd really recommend you guys check out WoodCode's video and even Van Zieben's series. And yeah, let me start off by showing WoodCode's code. I changed it a little, but this is pretty much from his tutorial. And in here, you could see that this is very like basic, which I like, because it just shows what's like important. But anyways, there's only 3 classes and that you have to write for this, and the first one is the server, and the second one is the client. And the client handler isn't technically necessary, but it's the best way of thinking of it. So the server is like the main code on the server side, where the server is hosted, and this has like the main method for the server class, and this as the main method for the client. And the client handler is run on the server side, and it allows the server to talk to clients without the server like getting kind of messy. Because with the client handler, you could just create a new client handler, and you can worry about it in this class rather than worrying about like everything in this class. But the most important things here are the server sockets, and the sockets and I guess also the buffered readers and writers. Yeah. So basically, the server socket is the server socket and also socket, and also the buffer reader and writer are all in Java's like default packages, and the server socket is what allows you, or it's what allows the server to accept new requests or accept new connections, basically. And when the server socket like has a new request for a connection and accepts it, it returns the socket, and the socket just represents the connection between, or yeah, it just represents this new connection. And you could send stuff through the socket and also receive stuff from the socket, and it's the same class in both the server and client side, so it doesn't really matter which side you're in. So you could say, I guess it's like symmetrical or something. But anyways, the way you send stuff through a socket is by using readers and writers, and in this specific case, our code decided to use buffered readers and writers, and this allows to write strings and integers, and also receive strings and integers. And yeah, if you do like buffered reader dot write and then, I don't know, type some random string, then on the client side, if you did buffered reader dot read or read line, then buffered reader dot read line would return whatever was written in the client handler, assuming these two sockets are like the same sockets. And pretty much the entire code just starts out with the server endlessly listening for new connections, and when a new connection is made, it creates a new client handler, and it tells the client handler to constantly listen for the client messages. And also, when a message is received, it goes through all of the client handlers and sends the received message to every single client, except for obviously the sender. And on the client side, it's pretty much similar. It starts out with I guess the username. That doesn't really matter, but there are two loops running at the same time. So there's the send message loop and the read message loop, and these two have to be like actively running at the same time, and you do that using threads. And yeah, the start message loop, or yeah, the read message loop, it reads from the terminal, and or wait, no, it's opposite. This refers to reading from the server and sending it to the client. And so this just constantly receives for a new string from buffered reader, and when it gets one, it prints it out just directly to the terminal. And also there's the send message loop where it constantly listens for something from the scanner, and when like a string is read from the scanner or the terminal, then it's sent to the buffered writer. And if you look at these two, it's actually pretty much the same thing, especially these two lines. It's just this is read from the terminal, send to the socket. This is read from the socket and send to terminal. And yeah, it's a simple and nice. But if you want to make a game, you're probably gonna have to use something other than buffered readers and writers, because it would be very hard to send a lot of information through just a string or an integer, because then you'd have to parse the string, and that's kind of annoying to do. So if we look at the same three classes, but for my program, there's the server, which has the server socket, and this also has the accept clients loop, which just constantly listens for a new connection and accepts it automatically. And yeah, it also creates new client handler. And the difference here is firstly that we can't just send strings, so we use an object output stream on both sides. And what this does is it allows for me to send any type of object. It doesn't have to be a string or an integer. It could be something like a hash map or a linked list, I think, or anything I want, even something I create on my own, as long as it's serializable. And that might sound complicated, like what's serialization, but all you as the developer have to think about is this line. And yeah, the moment you write this onto a class, then it becomes serializable, assuming all of its fields are also serializable. And there's additional things you could do with serialization, like making it so only certain things get serialized, or having like a custom method of serialization, but that's not really important because I don't do that a lot for my game. And yeah, you could make serialized like classes out of more complicated things. This client packet only has a serial version UID, and this number kind of helps with the serialization process to make sure it's more accurate or something. But Java should do a good job even without this, and it's just like a extra safety measure. And since action packet extends client packet, it also implies that it implements a serializable. So if I write like, yeah, there will be a warning that it already implements serializable, because that's how like inheriting works. And yeah, when I serialize an object in Java, it basically just means turning a Java object into a bunch of bytes. And unless you want to create your own custom serialization, Java automatically comes with a simple serialization process, which you don't have to worry about. And that's what I did. I didn't worry about the serialization. But the problem with that is if there's a malicious player, then there will be a safety risk, since when there's a carefully crafted object and Java deserializes it, so when it turns it from a bunch of bytes into an object, then it might end up running code that the server doesn't want to be run, and that's obviously a very bad thing. So if you're like trying to host this game, or even just making your own project with Java, that is something you should be aware of. But in my game, I don't think that's like that urgent of an issue, since you're probably just going to be playing it with your friends or by yourself. But yeah, just be aware that that is an issue. And other than the object input stream and output stream, the basic structure of these three classes is similar with the chat. So the server constantly accepts new connections. With that, it creates new client handlers, and the client handlers listens for messages from the client and reports it to the server. And it also can send objects from the server to the client, which is useful because it has to be both ways for the game to work. And the server sends a message to the client every frame. So in this case, it's 20 times every second. Or at least that's the maximum number of ticks per second. And yeah, it just calls send updates to all. And in this case, an update from the server is just going to be a hash map, or maybe it's a tree map, where the keys are entity IDs and the values are the entities themselves. And the client, when it receives that, it's going to have to update the game that, oh, these are all of the new entities. And it's also going to have to like update the data for each entity, since an entity might have moved from x equals 0 to x equals 1 or something like that, and it has to update all of the fields for everything as well. And when the client reads a message, as I said, it sends it to the game. It notifies the game that there has been a new update, and after that, it's gonna send its own message. It's gonna send a packet. In this case, it's called yeah, it's gonna be an action packet, and an action packet just contains all of the actions that the client wants to make, and it hasn't been made yet because the server takes care of all of the game logic. But here would be things like the client wanting to jump or move left or shoot. And yeah, after that, it resets all of the actions since the server has been notified. And yeah, that's pretty much it for this video. I hope you guys found this interesting, and yeah, I hope you guys have fun with this concept with Java sockets as much as I did, and see you in the next video.